All right, so in this video, we're going to make what we'll call the Molar Road Map. And if you take a piece of graph paper and you fold it down the middle, just so you have a general idea where the middle of the page is, we're going to label this Molar Road Map. And we're going to talk about the different conversions that are possible with the mole concept. The left-hand side of this is going to be labeled Substance A. And the right-hand side is going to be labeled Substance B. Now, for today, we're just going to focus on the Substance A side. But you'll see that eventually we'll learn how to convert between moles of one substance and moles of another substance, either in a chemical formula or in a balanced chemical equation. The next thing we're going to do is draw a series of boxes with arrows connecting them. And the first box that I want us to draw should be in the bottom third of the page. And I'm going to draw it big enough to write several words in. So it looks like I've used about, a 6x6 box or a 6x5 box, something like that. And that's going to be big enough for me to write the words grams of A inside. Just like that. And we're going to draw another box just about the same distance away, which is going to be labeled moles of A. Now I've left a little room between moles of A and the center of the page because the right-hand side of this page eventually will be a mirror image of the left-hand side. But the first thing that this diagram is going to illustrate is how we convert from either grams to moles or how we would convert from moles to grams. Here's an example of a problem where I've converted from moles of magnesium to grams of magnesium. And of course, the molar mass of magnesium is 24.305. So I've had to multiply by the molar mass of magnesium in order to have moles cancel and end up with grams. Of course, we know that 1 mole of magnesium is that many grams of magnesium. So notice when we are going from moles to grams, we multiply by molar mass. So I'm going to write multiply by next to the left-facing arrow, and inside this space I'm going to write molar mass because that is the conversion factor we're using, and multiply by is the operation I want to do in this direction. And of course, if instead, like in this problem, where I want to go from grams to moles, and I've used carbon as an example, you can see I've had to divide by molar mass because I want grams to cancel. I'm going to write divide by here. Now, this isn't really a substitute, this diagram, for thinking about dimensional analysis properly, but it should supplement our thinking about dimensional analysis, especially when we want to figure out how to go from, for instance, grams of one substance to particles of another substance, which we'll learn how to do later. So this is hopefully going to help us make a strategy for solving certain problems, but we still want to remember how to set up a dimensional analysis problem so we know what needs to be on the bottom of the conversion factor for it to cancel properly and so on. So this is going to show us how to get from grams to moles or moles to grams. The helpful thing about the mole concept is there's lots of places we can go from here. Once we know how many particles we have, or how many moles we have, we can convert to an actual number of particles. And I'm going to illustrate that with an arrow pointing up and an arrow pointing down to another box. We'll make this box the same size. And in this box, we're going to write particles of A, or number of particles of A. I'm I'm going to put an asterisk next to the word particles because I want to define that word very carefully. So I'm going to do that at the bottom of the page. Particles in chemistry can either be atoms, ions, or molecules. So how would I convert between moles and an actual number of particles? This is like going between moles and an actual number, or like going between dozen and an actual number, or going between score and an actual number. And if it was dozen, then I would multiply or divide by 12. And if it was score, I'd multiply or divide by 20. But since it's moles, I'm going to multiply or divide by Avogadro's constant. And I'll write that sideways. It's a little easier to fit it in there. 6.022 times 10 to the 23rd is Avogadro's constant. Now, do I want to multiply or divide by Avogadro's constant? Think about if you wanted to convert a quarter dozen to an actual number, you would take 1/4 and you would multiply by the number in a dozen, multiply by 12. So you can see here, if I wanted to convert a quarter mole of gold to an actual number of gold atoms, not in moles, then I would need to multiply by the number in a mole. So you know 3 dozen is 36. That's 3 times the number in a dozen. Well, 3 mole is 3 times Avogadro's constant. So if you want to convert from moles of A to particles of A, then you're going to need to multiply by Avogadro's number because you're going to get a huge number of particles. And if you want to go from particles to moles, you're going to divide by Avogadro's constant. Now this is a good place to stop and save the second half of this sheet for when we're ready to convert from moles of one substance to moles of another. If we're ready to continue with this Molar Road Map, then we can now talk about how we'll use a conversion factor to convert between moles of one substance and moles of another substance. And remember, a substance is an element or a compound. So first, we're going to draw a box here that is just like a mirror image of what's on the left, but in this case, we're going to be talking about substance B. So this is going to say moles of B. And this is going to say grams of B. And of course, if we want to convert between moles and grams, we'll use molar mass, just like we did in the first case. But of course, this would be the molar mass of A, and this would be the molar mass of B, of course, right? And if I want to convert between moles of B and particles of B, whether those particles are atoms, ions, or molecules, then of course, I'm going to need to use Avogadro's constant. And I put that asterisk next to particles again because we're sometimes going to need to remember that we may be talking about atoms or we may be talking about molecules when we're talking about particles or even ions. And of course, the same operators are going to apply here, going between particles and moles. This is 6.022 times 10 to the 23rd is our conversion factor. But the real important question now is how do we go between substance A and substance B? And this is going to be a conversion factor called a mole ratio. And there's two types of mole ratios that we'll encounter. Let's write the word mole ratio here. And I'm going to put another type of asterisk here and define this down here. A mole ratio can come from two different sources, a subscript in a formula, or it can come from a coefficient in an equation. And in these cases, I'm talking about chemical formulas and chemical equations. Now, the first type of mole ratio we're going to learn about and practice with is the ones that come from a subscript in a chemical formula. And we'll do some practice with that and talk about how, for instance, if I look at the chemical formula for water, H2O, there are 2 moles of hydrogen, which is one substance, for every 1 mole of water, which is another substance. If I look at CO2, carbon dioxide, and I look at the subscript next to oxygen, which is 2, that tells me there are 2 moles of oxygen, which is one substance, in 1 mole of CO2, which is a different substance. The second place that we're going to practice using mole ratios is when we look at balanced chemical equations. And this will come up later in second semester when we look at coefficients and equations to get mole ratios. That's something called stoichiometry. And we're going to wait until we've studied chemical reactions more carefully before we practice this. So I'm going to, at that point in time, remind you of this particular sentence, that right now we're going to limit our discussion to mole ratios that come from subscripts in a chemical formula. And we'll look at a few examples of that in class.